Hello viewers, in today's session we are going to discuss another important problem from beta and gamma functions, and here once again we are going to apply the concepts of beta and gamma functions to evaluate this integral. So here we have to evaluate this integral from 0 to 1, and we have x raised to 4 divided by the cube root of 1 minus x cube square, right? So let us call this integral as I, and let us start with the method of substitution, right? Because our aim is to convert this integral into the beta function, that is beta m comma n is equal to the integral 0 to 1, and we have t raised to m minus 1 1 minus t raised to n minus 1 dt, where m and n are greater than 0, right? So the first step is to convert this integral into the beta function by a method of substitution. So now let us substitute here. X cube is equal to t, right? So here we'll introduce this variable t such that x cube is equal to t, or x is equal to the cube root of t, right? So let us differentiate x with respect to t. So we can now write dx over dt is equal to d by dt of t raised to 1 over 3, and using the power rule for differentiation, we know that the derivative of t raised to n with respect to t is n times t raised to n minus 1. So here n is 1 over 3, so we have 1 over 3 t 1 over 3 minus 1, and this is 1 over 3 and t, and here we have 1 minus 3 over 3, that is 1 over 3 t, and minus 2 over 3. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us change the limits accordingly. So here the lower limit is x is equal to 0, and the upper limit is x is equal to 1. So when x is equal to 0, then the value of t can be obtained from this expression. So we have x is equal to 0, so 0 cube is 0, and when x is equal to 1, then the value of t is equal to 1 cube, that is equal to 1. So when x goes from 0 to 1, then t also changes from 0 to 1. So now we can easily write this integral I in terms of t. So we have t is equal to 0 to t is equal to 1, and for x we can write t raised to 1 over 3 raised to 4, and here we have x raised to 4, so taking x is equal to t raised to 1 over 3, and then we have the cube root of 1 minus x cube square. For x cube we can write t, and here we have square, and for dx we can write 1 over 3 t raised to minus 2 over 3 and dt, right? So now let us simplify this integral. So now we can write this integral I as 0 to 1, and here we can take this term 1 over 3 outside the integral. Then we have t raised to 4 over 3. Here we have t raised to minus 2 over 3 dt, and in the denominator we can write 1 minus t square, and here we have the cube root, so here we can write 2 over 3. So now this is 1 over 3 0 to 1, and here using the laws of exponents, we can write t raised to 4 over 3 minus 2 over 3, that is t raised to 4 minus 2 is 2, so this is t raised to 2 by 3. So here we have t raised to 2 by 3, and taking this term to the numerator, we have 1 minus t raised to minus 2 over 3 dt. So now what we have to do, if we see this integral and this integral, then we can easily conclude that here we have m minus 1, and here we have 2 over 3, and here we have 1 minus t raised to n minus 1, and here we have 1 minus t raised to minus 2 over 3. So let us write this exponent, that is 2 over 3 is equal to m minus 1, right? So we can solve this equation. So we have m is equal to 1 plus 2 over 3, that is 3 plus 2 over 3, that is 5 over 3. And similarly here we have minus 2 over 3, and here we have n minus 1. So solving this equation for n, we can now write minus 2 over 3 plus 1. So this is minus 2 plus 3 over 3, that is 1 over 3, right? So now we can write this integral as 1 over 3, 0 to 1, and t raised to 2 over 3 can be written as m minus 1, right? Because we want to convert this integral into this form. So 2 over 3 is equal to m minus 1, and m is 5 over 3. So we can now write t raised to 5 over 3 minus 1, because 5 over 3 minus 1 is again 2 over 3. And then we have 1 minus t raised to minus 2 over 3, and n is 1 over 3, so minus 2 over 3 is 1 over 3 minus 1, and here we have dt, and 1 over 3 minus 1 is minus 2 over 3. So now this integral is similar to this one, that is this is the beta function. So now we can write 1 over 3, and this integral is equal to the beta function, that is beta m comma n. So here m is 5 over 3, and n is 1 over 3. So now we have to calculate the value of this beta function by using the relationship between beta function and gamma function. So now the beta function and gamma function are related by this expression, that is gamma m, then we have gamma n divided by gamma m plus n. So now this integral I is equal to 1 over 3, and beta 5 over 3 comma 1 over 3 is equal to gamma 5 over 3. Then we have gamma 1 over 3, and here we have gamma 5 over 3 plus 1 over 3, right? So this is 1 over 3 and gamma 5 over 3, and then we have gamma 1 over 3, and here 5 plus 1 is 6, 6 over 3 is 2, so we have gamma 2. So now to get the value of gamma 5 over 3, let us make use of this important result, that is gamma n plus 1 is equal to n times gamma n, right? So if we take gamma of 5 over 3, then gamma 5 over 3 can be written as, here we can write 2 over 3 plus 1. Right? So we can split 5 over 3 as 2 over 3 plus 1. So if we compare this expression with this one, then n is 2 over 3. So here we can now use this expression. So we have 2 over 3 times gamma 2 over 3. And gamma 2 is equal to 1, because we know that gamma n plus 1 is equal to n factorial when n is a positive integer, right? So gamma 2 can be written as gamma 1 plus 1, and that is 1 factorial, that is equal to 1. So now we can write this expression as 1 over 3. Gamma 1 5 by 3 can be written as 2 over 3, gamma 2 over 3, and then we have gamma 1 over 3, and in the denominator we have 1. So now here we can multiply these two fractions. So we have 2 over 9, and then we can now write this 2 over 3 as 1 minus 1 over 3, right? So the purpose of writing 2 over 3 as 1 minus 1 over 3 is to make use of the famous Euler's reflection formula. So gamma 2 over 3 can be written as 1 minus 1 over 3, and here we have gamma 1 over 3. So now let us look at this expression. So we know that from Euler's reflection formula, that is gamma 1 minus n times gamma n is equal to pi over sine n pi, right? So if we take n is equal to 1 over 3, then this left hand side it appears as 1 minus 1 over 3. Then we have gamma 1 over 3, and here we have pi over sine n pi. So n is 1 over 3, so we have sine pi by 3. So now we have pi, and sine pi by 3 is sine 60 degrees, that is root 3 over 2. So we can now write 2 pi over square root of 3. So now the value of the integral I is equal to 2 by 9 times gamma 1 minus 1 over 3 times gamma 1 over 3, and the value of this expression is equal to 2 pi over square root of 3. So we can now multiply 2 and 2 pi, so we have 4 pi over 9 root 3. So viewers, the value of this given integral is given by 4 pi divided by 9 times square root of 3. Hello viewers, in today's session we are going to discuss another important problem from integration, and here we have to evaluate this integral that is from 0 to infinity, and we have x raised to 5 divided by 1 plus x cube raised to 5 over 2 dx. And here we are going to make use of the concept of beta and gamma functions to evaluate this integral. And before applying the concept of beta and gamma functions, let us first make use of the method of substitution to convert this integral into a beta function, that is beta m comma n is given by the integral that is 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n dt. So by a method of substitution, we'll first convert this integral into the beta function. So now let us first substitute t is equal to x cube, right? So that this term becomes 1 plus t raised to 5 over 2. So we'll take t is equal to x cube, and this implies that x is t raised to 1 over 3. So let us differentiate x with respect to t. So we have dx over dt is d by dt of t raised to 1 over 3, and making use of the power rule, we have nt and n minus 1, right? So here the value of n is 1 over 3. So we have the derivative of t raised to 1 over 3 with respect to t as 1 over 3 t raised to 1 over 3 minus 1. So this is 1 over 3 t raised to 1 minus 3 over 3 1 over 3 t raised to minus 2 over 3. So now dx over dt is equal to this expression. So now we can write dx is equal to 1 over 3 t raised to minus 2 over 3 and dt. So now let us change the limits accordingly. So here x varies from 0 to infinity, right? So when x is 0, 0 is the lower limit. The value of t can be obtained from this relation. So we have 0 cube, that is 0, and when x tends to infinity, that is the upper limit, then t also tends to infinity due to this result, right? So now let us write this integral I in terms of t. So we can now write 0 to infinity, and then we have x raised to 5, x is t raised to 1 over 3. So we have t raised to 1 over 3, and here we have 5. For dx, we can now write 1 over 3 t raised to minus 2 over 3 dt. And in the denominator, we can write 1 plus t raised to 5 over 2. So now let us arrange the terms here, and we can simplify. So we can take 1 over 3 outside the integral. We have 0 to infinity. Then here we have t raised to 5 over 3, and here we have t raised to minus 2 over 3, and here we have 1 plus t raised to 5 over 2 and dt. So now we can write I is equal to 1 over 3 0 to infinity, and here we can apply the laws of exponents. So here the base is same, so we can add the powers. So we have 5 over 3 plus minus 2 over 3, that is 5 minus 2 over 3, that is 3 over 3, and that is t raised to 1, right? So in the numerator we have t raised to 1, and here we have 1 plus t raised to 5 over 2 dt. So now let us compare this integral with this one, right? So here we have 0 to infinity, here we have 0 to infinity and t raised to 1. Here we have t raised to m minus 1, and here we have 1 plus t raised to 5 by 2, and here we have 1 plus t raised to m plus n. So let us find out the values of m and n in order to express this integral in this form. So we can now compare both these integrals. So we have m minus 1 is equal to, so we have m minus 1 equal to 1, and then m plus n is equal to 5 over 2. So let us solve this equation. So we have m is equal to 1 plus 1, taking minus 1 to the right hand side. So we have 2, and then taking m is equal to 2 in this equation, we have 2 plus n is equal to 5 over 2. So n is 5 over 2 minus 2, that is 5 over 2. This is 4, and 5 minus 4 is 1. So we have 1 over 2. So now we can write this integral I as 1 over 3 0 to infinity and t raised to 1. So 1 can be written as m minus 1. So m is 2, so we can write 2 minus 1, and here we have dt, and 1 plus t raised to 5 over 2. So 5 over 2 is m plus n. M is 2, and n is given by half, right? So now this integral is exactly of this form. So now the value of m is 2 and the value of n is half, so this is our beta function. So we have 1 over 3 times the beta function m comma n. M is 2 and n is half. So let us now calculate the value of this beta function with the help of this important relation between beta function and gamma function. So beta function is equal to gamma m times gamma n divided by gamma m plus n. So here we have 1 over 3, and then we can now write gamma 2. Then we have gamma half, and in the denominator we can write gamma 2 plus half. So we can now write the value of I as 1 over 3, and gamma 2 is equal to 1, because here we can use this result gamma n plus 1 is equal to n factorial, where n is some positive integer. So if we take n is equal to say 1, then here we have 1 plus 1 2. So gamma 2 is 1 factorial, that is simply 1, right? And here we have gamma half. So gamma half can be written as square root of pi. So here we have square root of pi, and in the denominator we have gamma of 5 over 2. So now let us write the value of gamma of 5 over 2 with the help of this relation, that is gamma n plus 1 is n times gamma n. So here gamma 5 over 2 can be written as 3 by 2 plus 1. We can split 5 over 2 as 3 by 2 plus 1. So now our n is 3 by 2. So taking n is equal to 3 by 2, in this relation we have 3 by 2 gamma 3 by 2. And further we can split 3 by 2 as half plus 1. So now we have 3 by 2 half times gamma half. So again applying this result to this expression. So now we have 3 over 4 gamma half. Gamma half is square root of pi. So substituting the value of gamma 5 over 2 as 3 by 4 times square root of pi, we can now write the value of I as 1 over 3. This is root pi, and here we have 3 by 4 times square root of pi. So these two terms get cancelled, and we have 1 over 3 times 4 over 3. So we'll take the reciprocal of 3 by 4. So here we have 4 over 9. So viewers, the value of this integral is equal to 4 divided by 9. Hello viewers, in today's session we are going to discuss two important problems from integration, and here we have to evaluate these two integrals with the help of the concept of beta and gamma functions, right? So let us solve these integrals one by one. So let us first consider this integral, and let us call this integral as I, right? So here we'll solve this integral with the help of beta and gamma functions. So let us start with the method of substitution, right? So the method of substitution reduces this integral into the beta function, which is defined as beta m comma n, that is equal to the integral 0 to infinity, and we have t raised to m minus 1 divided by 1 plus t raised to m plus n and dt, right, where m and n are greater than 0. So here we'll first reduce this integral into the beta function, and let us first take x square is equal to t, right? So x can be written as square root of t. let us differentiate x with respect to t. So we have dx over dt is equal to the derivative of square root of t, and the derivative of square root of t is 1 over 2 times square root of t. So now we can write dx is equal to dt, and here we have 2 times square root of t. So now let us change the limit. So here x varies from 0 to infinity. So when x is equal to 0, then the value of t can be obtained from this equation or this relation. So t is equal to 0 square, that is equal to 0. And when x tends to infinity, then from this relation we can see that t also tends to infinity. So when x changes from 0 to infinity, t also varies from 0 to infinity, right? So the limits remains the same. So now this integral I can be written in terms of t. So we have 0 to infinity, and x square can be replaced by t, and then we have 1 plus t raised to 2, and for dx we can write dt divided by, here we have 2 times the square root of t. So now let us rearrange the terms. So we can take half outside the integral, and we have 0 to infinity. Here we have t raised to 1, and here we have t raised to half. So we can take t raised to half to the numerators, and applying the laws of exponents we can write 1 minus half, and here we have 1 plus t raised to 2 and dt. So let us write it like this, that is 0 to infinity, and t raised to 1 minus half is half, right? And here we have 1 plus t square, and here we have dt. So now this integral is reduced to this one along with this factor half, right? So now if we compare this integral with this one, then we can see that here we have half, and here we have m minus 1. So we can write m minus 1 is equal to half, and here we have 2, and here we have m plus n. So m plus n can be equated to 2, right? Because we wish to express this integral like this. So we can solve these two integrals for these two equations for m and n. So m is 1 plus half, that is 3 by 2, and from here n is 2 minus m. So this is 2 minus 3 by 2, that is 4 minus 3, that is half, right? So now we can write this integral as half and 0 to infinity, and t raised to half can be written as m minus 1. M is 3 by 2. So here we have 3 by 2 and minus 1, and then we can write 1 plus t, and here we have 2. So 2 can be written as m plus n. M is 3 by 2, and n is half, right? Okay, so now this integral is exactly of this form. So we can now write it as half, and beta function, that is beta m comma n. M is 3 by 2 and n is half. So now we have to find out the value of this beta function using the relationship between beta function and gamma function. So beta m comma n is related to gamma function as gamma m. Then we have gamma n, and then we have gamma m plus n. So here we have half. We can write gamma 3 by 2. Then we have gamma half, and here we have gamma 3 by 2 plus half, that is m plus n, and m plus n is 2. So here we can write 2. So now the integral I is equal to half, and gamma 3 by 2 the value of gamma 3 by 2 can be written as gamma half plus 1. So we can split 3 by 2 like this, half plus 1. So we have half times gamma half, right? Using this result, that is gamma n plus 1 is equal to n times gamma n. So now gamma half is equal to square root of pi. So now we can write half, and here gamma 3 by 2 is half times square root of pi, because gamma 3 by 2 is half times gamma half, that is half root pi, right? And gamma half is square root of pi, and in the denominator we have gamma 2. Gamma 2 can be written as gamma 1 plus 1, that is 1 factorial, that is equal to 1, right? Because we know that gamma n plus 1 is equal to n factorial, where n is some positive integer, right? So here we have 1, so this is half times half is 1 over 4, and here root pi times root pi is pi, right? So we have pi over 4. So the value of this integral I is equal to pi divided by 4. So now let us consider the second problem. So here let us take this integral as I, right? And here also we'll start with the method of substitution, right? And then we'll convert this integral into this form. So let us substitute here. T is equal to x raised to 6, right? So x can be written as the sixth root of t, that is 1 t raised to 1 over 6. Now let us differentiate x with respect to t. So we have dx over dt is equal to d by dt of t raised to 1 over 6, and applying the power rule, that is the derivative of t raised to n is n times t raised to n minus 1. So here the value of n is 1 over 6. So we have 1 over 6 t raised to 1 over 6 minus 1, that is 1 over 6 t raised to 1 minus 6 over 6, that is 1 over 6 t raised to minus 5 over 6. So now we can write dx is equal to 1 over 6 t raised to minus 5 over 6, and here we have dt, right? Okay, so now let us change the limits accordingly. Here x varies from 0 to infinity. The lower limit is 0, the upper limit is infinity, right? So when x is equal to 0, then the value of t is given by this relation, that is 0 raised to 6, that is 0. And when x tends to infinity, then from this relation we can easily conclude that t also tends to infinity, right? So when x varies from 0 to infinity, t also varies from 0 to infinity. So in this case also the limits remains the same. So now let us write this integral I in terms of t. So we have 0 to infinity, then we have x raised to 4, right? So here x is t raised to 1 over 6. So we have t raised to 1 over 6, and then we have 4 here, and x raised to 6 can be written as t, and this is t plus 1, and for dx we can write 1 over 6 and t raised to minus 5 over 6, and here we have dt. So now let us rearrange the terms, and taking 1 over 6 outside the integral, so we have 1 over 6 0 to infinity, and here we have 4 over 6, right? And here we have t raised to minus 5 over 6. So applying the laws of exponents, we have t raised to 4 over 6 minus 5 over 6, and in the denominator we have simply 1 plus t, and 1 plus t can be written as 1 plus t raised to 1, and here we have dt. So now we can write 1 over 6, 0 to infinity, and here 4 minus 5 is minus 1. So we have t raised to minus 1 over 6, and here we have 1 plus t raised to 1 and dt, right? So following the same steps which we have done in evaluating the first integral, let us compare this integral with this one. So here we have minus 1 over 6, here we have m minus 1. So we can now write m minus 1 is equal to minus 1 over 6, and m plus n is equal to 1, right? So from here m is 1 minus 1 over 6, that is 6 minus 1 over 6, that is 5 over 6, and the value of n is 1 minus m, that is 1 minus 5 over 6, that is 6 minus 5 over 6, that is 1 over 6, right? So now we can write this integral I as 1 over 6. We have 0 to infinity, and t raised to minus 1 over 6 is m minus 1, and m is 5 over 6. So we can write 5 over 6 minus 1. Here we have dt, and 1 plus t raised to 1. 1 is m plus n, right? M is 5 over 6, and n is 1 over 6. So 5 over 6 minus 1 is minus 1 over 6, and 5 over 6 plus 1 over 6 is equal to 6 over 6, that is 1, right? So this integral is now exactly similar to this one. So we can now write 1 over 6, and we have the beta function, that is beta m comma n. M is 5 over 6, and n is 1 over 6. So let us now calculate the value of this expression. So using the relationship between beta function and gamma function, we have gamma 5 over 6, then we have gamma 1 over 6, and here we have gamma 5 over 6 plus 1 over 6, right? So now I can be written as 1 over 6, gamma 5 over 6, gamma 1 over 6, and in the denominator we have gamma 5 over 6 plus 1 over 6 is simply 1, gamma 1 is 1, right? So in the denominator we have 1, and now to evaluate this expression, we have to make use of Euler's reflection formula. So now Euler's reflection formula goes like this, that is gamma 1 minus n times gamma n is equal to pi divided by sine n pi, right? And if we take n is equal to 1 over 6 in this result, then we have gamma 1 minus 1 over 6, and then we have gamma 1 over 6, and that is equal to pi divided by sine pi over 6. So gamma 1 minus 1 over 6 is gamma 6 minus 1, that is 5. So we have 5 over 6, then we have gamma 1 over 6, and this is equal to pi divided by sine pi by 6. Now sine pi by 6 is sine 30 degrees, that is equal to half, right? So here we have half, taking this half to the numerator, we have 2 pi. So this product, that is gamma 5 over 6 times gamma 1 over 6 is 2 pi. So let us substitute this value over here. So we have I is equal to 1 over 6 times 2 pi, and here 2 times 3 is 6. So we have pi over 3. So the value of this integral I is equal to pi over 3, that is pi divided by 3. So viewers, this is how by the application of beta and gamma functions we can easily evaluate these kind of integrals.